I'm Kaikit. I will explain about the sample calculations part. First of all, the reaction in this experiment 3 measure chemical reaction rates in plug flow reactor PFR is ethyl acetate mixed with sodium hydroxide to produce sodium acetate and ethyl alcohol. Step 1. We calculate the concentration of unreacted NaOH. By using the data at time t equal to 10 minute and temperature T equal to 50 degrees Celsius, concentration of unreacted NaOH is moles of unreacted NaOH in the sample divided by volume of the sample times 1000 mole per liter, and we get 0.029 mole per liter. Step 2. We calculate conversion X. Conversion X is the ratio of feed consumed or the ratio of the product formed. In this experiment, conversion is concentration of NaOH that has reacted divided by initial concentration of NaOH. So the concentration of NaOH reacted is the initial concentration minus the concentration that has reacted, and we get 0.7070. Step 3. We calculate reaction rate constant K. Reaction rate constant in chemical kinetics quantifies the rate of a chemical reaction, and it depends on temperature. Its formula is 1 over tau Ca0 times x over 1 minus x. By plug in Ca0, x, and tau, we will get final value of K is 5.440 liter per mole per minute. And we come to the final step, step 4, which is calculation of rate of reaction. Since it is a second order reaction, we use the formula negative Ra equal to KCa0 square 1 minus x square. By plugging in the value of KCa0 and x, we will get negative Ra equal to 4.58 times 10 to the power of negative 3 mole per liter per minute. Conclusion part. At 50 degrees Celsius, theoretical conversion is 0.9980, while the experimental conversion is 0.7070. The error we get is 29.16%. At 60 degrees Celsius, theoretical conversion is 0.9982, but the experimental conversion is 0.6680 with an error of 33.08%. Overall, the theoretical result simulated by Aspen has large deviations compared to experimental result. The error might caused by the problems that occur in the experiment, which is the flow rate of the feed solutions is not monitored constantly with regular checks. Hence, there is deviation in the concentration of NaOH samples collected. So what should we do? To improve the accuracy of the result, there is some recommendation. First, 5 ml of HCl should be added into the sample taken immediately to stop the saponification reaction. Secondly, parallax errors must be avoided when taking the reading of the volume of NaOH used in the burette during the titration and measurement of solution volume. Third, titration should be carried out carefully in order to make sure that the pH of the analyte is exactly 7. Fourth, the flow rates of the ethyl acetate and sodium hydroxide should be adjusted constantly to make sure that they are in a range of plus minus 10%, because a large deviation in the flow rates will affect the accuracy of the result. Lastly, the conductivity should be taken after it shows 3 constant readings before the sample is taken out from the reactor. So that's all from me. Thank you very much.